remind you that today is open house, so open house is from 6 to 8 tonight. Hopefully we may or may not see your parents. I'd love to see them, but if in case you're curious what the spiel is, it's basically like a first day, but then only in 10 minutes. So, no, I don't give extra credit. No. So, and the only other thing I'm going to show your parents, because I think that is actually useful that they know what you can find on Student View. So, specifically talking about the class website, the extra credit announcements, and the homework, and the uploaded video lecture, and the homework, and the pictures, and everything's on the class website, right? So, hopefully you're all aware of that and are utilizing that. All right, today we're talking about rational fractional expressions some more, specifically getting to complex fractions. And complex fractions, a complex fraction is when I have a fraction within a fraction. So like 3/8 divided by 4/5, let's say. So this is a fraction divided by another fraction. And can seem really complicated. So what I'm going to have us do is say, hey, well, let's just rewrite this a little bit differently and say this is 3/8 divided by 4/5. And now when you see a fraction divided by a fraction, I bet you know how to deal with that. What do you do to deal with that?
You keep change.
Keep, change, flip, sure. We multiply by the reciprocal, all right? And so we can do 3/8 times 5/4, which would then just be 15/32. Okay? And so we're doing a very similar thing. Hi.
Hi, when you check your roster for today, will you let me know if I'm on your PLC list?
Oh, okay.
Because we're doing, do you know what I mean? I know, but
Okay. All right. I'll try. Ask Hattie. Okay. I'll do my best. I don't think.
well, no, because I know that I need to meet with the math team and the language teams, because those are the friends, just carefully strong. Okay, so if I'm not on there, I may have to.
All right. There we go. So example 1, perform the multiplication or division and simplify. So we did some simplifying yesterday. To simplify rational expressions, you factor first. And that is the rule. Like all the time, factor first applies. If we factor, then we can pop those bubbles. And that's usually how I talk about it. Because so many students like to say, hey, here's an x cubed and here's an x cubed. And I can just cross those off, right? It doesn't work that way. And so you can't do that. Addition and subtraction are really strong bonds. They're totally unbreakable bonds. Multiplication is really flimsy. When things are connected by multiplication, then you can pop those bubbles. So that's really how I think about it. All right. So letter A here. We need to do a bunch of factoring. And so we went over all the different ways we can factor. And that's going to come in really useful. But of course, we have a division problem, but I'm not going to divide. What am I going to do instead? Multiply by the reciprocal. And that's the reciprocal of that second fraction. Keep, change the sign, flip the fraction. So I'm going to deal with that in just a minute. To get started, I'm going to go ahead and think about trying to factor right here, x cubed plus 8. What is that called, x cubed plus 8? Difference of cubes. Very good. Difference of cubes. Difference of cubes. Now, we went over difference of cubes. What is difference of cubes? What do you remember about difference of cubes? 2 bubbles. Small bubble, big bubble. Small bubble, big bubble. What are the signs for difference of cubes? Minus, plus, plus. Yeah. So the sign starts the same. The second one is going to change. And the third sign is always positive. Okay? So minus, plus, plus. Now, we take the roots here. What is being cubed to get x cubed? X, And what times what is 8? 2. And to fill in my second bubble, we square the first thing. What is x squared? X squared, yeah. In the middle, we multiply. And you just take your numbers and multiply them together. X times 2, 2x. And then you square the last thing and pop it in there. And 2 squared is 4. Same every time. Square the first, multiply in the middle, square the last. All right. On the bottom, we have x squared minus 4. What's that called? Difference of squares. Difference of squares. Difference of squares factors as what? X plus 2, x minus 2. Very good. Now, I'm changing the sign, which means I'm also going to flip my fraction. And so now I'm going to have this x cubed plus 8 is going to be on top. I want to factor that. What's that called? Sum of cubes. Sum of cubes. So again, same idea. Small bubble, big bubble. What are the signs for sum of cubes? Plus, minus, plus. Again, keep the sign. Change the sign. Always positive. Plus, minus, plus. Keep the sign, change the sign, always positive. All right. And then we can, again, take the root here. The cube root of x cubed is x. Cube root of 8 is 2. And we're going to square the first thing. Multiply in the middle. And square the last thing. All right. And then the very last thing we have going to be on the denominator right here, x squared plus 2x plus 4. Can I do anything with that? No, this is actually prime. It does not factor. You might think that it's x plus 2 and x plus 2, but that doesn't actually work if you check the rainbow. All right, so that one does not factor. We're going to leave it x squared plus 2x plus 4. Now that it's all entirely connected by multiplication, we've got a bubble times another bubble times another bubble, and all of these bubbles on the bottom are also multiplied. Now we can reduce. So what's going to reduce for us? X minus 2 over x minus 2 reduces to 1s. X plus 2 reduces to 1. Yeah, I think you won that one. Good job. Okay. All right. Good. So all those bubbles that match pop one for one. You'll notice I can't pop this one over here because it's only one on top and one on bottom. All right. Pop, pop, pop. Yeah. All right. And so here is our final answer. You should know, I'd like to point out that when we use the difference of squares, difference of cubes or sum of cubes, will you ever be able to factor that second bubble, that big bubble? No. You cannot factor it, which also means that if you tried to solve using, like, say, the quadratic formula, which we'll do tomorrow, if you tried to solve, it would end up being imaginary. Okay. All right. Do you guys have any questions for me?
We're ready.
Example 2.
It was there.
All right. Example 2, simplify. Here we have. We are adding adding and subtracting fractions. What do you need in order to add and subtract fractions? Common denominator. Really important. And so, especially on this first one here, we want to, our same rule apply, factor first, is always a good strategy. And so I am going to think about trying to factor that. So I have 3 over x minus 1, and I want to try and see if I can factor my denominator there. Does x minus 1 factor?
No.
No. I'm going to use a different color. All right, so x minus 1 does not factor. It's prime. You can't take anything out of it. Then I have a minus 2 over an x plus 1. Does x plus 1 factor? No, it's also just prime. Can't do any double bubbling with that. And then I have a plus x plus 3 over x squared minus 1. Does x squared minus 1 factor? Yeah, how does it factor? Yeah, x plus 1. Oh, man. X minus 1, x plus 1. Good. All right. So I like to color code things like this because I think this really helps. Now, when we're looking for common denominators, we want to look at those factors in the denominator and just make sure that every single fraction has all the same parts. So here, my third fraction has the blue factor and it has the pink factor. So when I look at my first fraction, what does that need? Yeah, it needs the blue x plus 1. And whatever I do to the bottom, I have to do to the top. And I look at my second fraction. It has the blue factor. What does it need? A pink factor, x minus 1, on top and bottom. Now, the nice thing is once you get all those denominators to match, I no longer have to keep them separated, and I can just write them, my fractions, one giant numerator over one denominator. They all share the same denominator. And we get to do some multiplying in our numerator. So we need to distribute the 3. What do we get when we distribute the 3? 3x plus 3. And then what should I distribute? Just the 2?
2x.
Just the 2? Negative 2. Always, always, always include the sign and make sure you're distributing it because you have to subtract the entire fraction. So what do we get when we distribute the negative 2? Negative 2x plus 2. Good. And then I have nothing here, so it's just a big plus x plus 3. Once we do that, I can combine like terms. So I have a 3x, a minus 2x, and a positive 1x, which gives me what? 2x. And I have a positive 3, and a positive 2, and a positive 3, which gives me 8. A lot of chatter. Is there a question? Yeah. All right. Is there anything else we should do? Take out the 2. Yeah. GCF. Always a good idea to double check to see if there is a greatest common factor. And we want to take out that 2 if we can. So what's left behind if I take out the 2? X plus 4. Good. Now, the reason we would want to take out that 2 is really just to see if we can simplify our fraction anymore. Any other bubble's going to pop because, of course, we want to reduce our fraction if we can. But nothing cancels here, so we're just going to leave it just like this. And it's a perfectly wonderful answer. Solution, I would say. Simplification. There, that's better. All right. questions on A? Okay, letter B. Letter B is a complex fraction. And so I'm going to do, I don't like it in this form. Maybe you do. I'm going to switch it and rewrite it as 2 over x minus 3 divided by 1 minus 1 over x minus 1. So I'm going to write it out like that because I think it's, I don't know, less threatening maybe? I don't know. But you'll notice we need to work inside of these parentheses because I have a fraction minus a fraction. What I need to do is I need to consolidate that into a single fraction. So I need to function within these parentheses first to clean up my fraction. Now, I will tell you that there are lots of ways to do this, so you might have learned another way, especially if you're in college algebra last year, which is multiplying by the LCD. But that's a hit or miss topic usually, so I go common denominator. So I want to get a common denominator for both of these individually. So I've changed my 3 into a fraction so that I'm looking at a fraction minus a fraction. What does that 3 need so that I have a common denominator? Yeah, it needs that x. There's an x over here. I need an x on that second fraction. So I'm going to multiply top and bottom. So that gives me a denominator of x. And what's my numerator then? 2 minus 3x. Good. All right. Now I'm going to do a similar thing over here on my fraction on the right. This is really 1 over 1. Do they have a common denominator? Nope. This has a denominator of x minus 1. What should I multiply my 1 by? X minus 1 on top and bottom. And so now they both have that common denominator of x minus 1. And what's in my numerator now? X minus 1 minus 1, or x minus 2. I'll simplify that on the next go around. So now that I've simplified my fractions, I've condensed them into a fraction, a single fraction, divided by another single fraction. Now I can do the whole keep, change, flip operation. So I'm going to keep this to, minus 3x over x. I'm going to change the sign to multiplication. Now what's in my numerator on my second fraction? X minus 1, and what's in the denominator? X minus 2, very good. And so now we're just multiplied straight across. Everything's in factored form. Does anything pop? Does anything cancel? Nope. So we just multiply straight across, and I'm just going to leave it in factored form. Sometimes things will reduce, and sometimes things won't. But this is a perfectly acceptable final answer. All right. Do you have any questions for me? All right, ladies and gentlemen, you can start on class practice 10.
Thank you.
What? No, bro. I'm calling bro, you serious?
Alright, ladies and gentlemen. You're looking at the problem number 47 and thinking, what? Okay, so what does the directions say to do on number 47? Alright, what's a ratio? A fraction. Okay, a fraction of what? The shaded portion over the total area. Okay, so looking at your picture on number 47, what is the shaded area? Oh, a circle. Oh, okay, a circle. And how do you find the area of a circle?
Pi times radius squared.
Pi r squared. Pi r squared. What's your radius?
R.
Oh, r. Great. Use r. Okay, pi r squared. All right, perfect. So that's on the numerator. We're supposed to divide by the total area. What is the shape of the total area? A square. How do you find the area of a square? Length times width. Okay, look at that square. What is the length?
Oh, it's on my dice.
2r. 2r. So the length is 2r. What's the height? 2r. What's the area of the square? 4r squared. 2r times 2r is 4r squared. What's in your numerator? Pi r squared. What's in your denominator? Does something reduce?
Wait, how did the division work? It's like that minus the shade. Oh, the ratio.
Shade over total area. Yeah.
Yeah. 4/5.
48 times 40. I'm gonna have to talk through what I did on 48. Not quite there. Wait, it's
If it goes strong, I'm actually kidnapping you. You're staying here. Me too. But that's why. Probably spend. Oh, so now.